Prior to CumuLogic, he has spent more than 11 years at Goldman Sachs in various infrastructure roles and as an application infrastructure architect for risk technology. Chip Childers is the Vice President of Product Strategy of CumuLogic. Chip's previous roles was as Chief Architect for SunGuard's cloud service offerings. He also served as the first Vice President of Apache Cloud Stack for the Apache Software Foundation. Throughout our presentation, we encourage you to submit questions using the questions pane on the GoToWebinar. We will answer questions live at the end of the presentation. Please keep in mind that all participants are in listen-only mode. We are recording today's session, and we'll email a link to the recording tomorrow and post links on the CumuLogic website. Let's get started. We'll kick off today's webinar with Chip. Chip, over to you.
Thanks, Jack. Good morning, good afternoon, or good evening, wherever you are today. Thank you very much for joining us. As Jack said, we're going to walk through a little bit of a set of slides that will describe the CumuLogic platform and some of our capabilities for handling MySQL and Percona databases. Then we'll hand off to Sandeep, and he's going to walk through a demo of the product itself, and then we'll have time for taking questions near the end. So before I get started talking specifically about our SQL database services, I want to step back a little bit and to give you some context about what the CumuLogic platform is actually all about. The premise behind CumuLogic software is that we're working hard to allow cloud operators, IT teams, really anyone with some infrastructure to move beyond just dealing with virtual machines. We found that if you look at the largest cloud providers, they've demonstrated that application owners really have a strong desire for services like SQL database as a service or NoSQL services, or even caching, load balancing, message queues, simple app deployments. And so our platform, while extremely strong on the database as a service, both SQL and NoSQL features, does have additional capabilities that can be used. Drilling in specifically, though, to our Relational Database as a Service module, let's talk about this for a second. This functionality has been designed to approximate Amazon's RDS capabilities. The way that it works is that an end user is presented with a very simple interface to specify how large they want the deployment to be, whether it's a single node deployment or it's potentially a multi-node Percona cluster. They're given the ability to create replica sets or replicas of that master system. And the software goes through the process of relying on the underlying infrastructure to get virtual machines or even just to allocate a bare metal system for each node of the service that's being requested. So a single node MySQL would be one VM or one bare metal server. A multi-node cluster would be multiple VMs or multiple bare metal servers. Once provisioning is complete, the controller, it doesn't stop there. It actually then maintains monitoring telemetry into the targeted database that's been deployed. It will provide end users with feedback around performance as well as capacity metrics. It will deal with scheduled jobs, like, for example, backups are done on a nightly basis with a customizable retention period. It's also able to handle things like a fault that might be experienced within a cluster. If a node goes offline within a cluster, that's identified and a new node is brought back online and rejoined to the cluster. It's also very easy to think about your deployments in terms of levels of availability. And so as a user, you really can just say, I would like one system, single node deployment for dev and test. It's useful to have backup that kind of comes along for free when you deploy in that way for a development system. But then you could very easily then take that same system and begin to scale it up. So if it's MySQL, you can begin to add read replicas. You can even deploy those read replicas across multiple geographies. And we'll walk through some of the deployment scenarios in a second here. Now, for those of you that are here from the enterprise space, the value here should be very clear. We're going to automate around 75 to 90% of the manual operational tasks. involved with provisioning, as well as a good percentage of those involved with maintaining the database itself. Really what we want is that we want your DBA teams to be able to get themselves out into the development organizations to focus on database best practices. Get them out of the business of just doing repetitive, easily automated tasks. The other thing it does is as those DBA teams move out into the development teams and begin to partner better, you really are in a position where you're empowering the line of business developers or the application teams within the IT group to very quickly self-serve for everything from development all the way up through production-grade systems. And they can do it inside the firewall. Now, the last point that we'll make for the enterprise folks is that we actually are able to support this type of capability both inside your firewall, running on vCloud or Eucalyptus or OpenStack or CloudStack based infrastructure, or even just bare metal or basic virtualization environments. But we can also allow you to deploy some of your applications out into public cloud providers because we support all of those underlying APIs. And so lots of our customers are interested in the idea that you push your dev and test systems out into perhaps Amazon while keeping your production and staging systems in your data center for the purposes of compliance, performance, or even latency. There's lots of reasons why you'd want to keep things in-house. On the service provider side, obviously this is going to help drive infrastructure consumption. If you offer the CumuLogic platform in conjunction with the virtual machine services, the more data you have in your platform, the more likely it is that you'll see more virtual machines. We offer, since we offer a variety of services, it's very quick to just add new additional revenue streams for yourself. And honestly, you would then begin to have an answer for somebody, a potential customer that looks at you and says, but I don't want to have to manage my own databases. Amazon doesn't make me do that because it's only a few clicks to get a Amazon RDS instance that's fully backed up and managed. Now, in terms of the database service itself, I've mentioned that it's got AWS feature compatibility, and that really is the pattern that we used for how we designed this module. This includes the ability to create discrete instances that are sized based on the underlying infrastructure's capabilities. So what that means is the types of virtual machines that the databases would be deployed on is selectable by the end user. Each individual deployed node is a virtual machine. And that includes replicas. And so if you take a MySQL database that might start out life as a single node, adding additional read-only replicas that might span multiple availability zones or data centers or infrastructure targets is a very straightforward process. The parameter groups, this is something that we'll hit just in a minute, but the general idea here is that while databases have been abstracted to the level that a user is able to select the right engine and not have to worry about some of the configuration details, there is a value in puncturing that abstraction slightly in order to allow experts who understand the engine that they've selected to fine-tune some of the configuration parameters that are being pushed out to the database itself. Database snapshotting, both regular scheduled backups as well as on-demand backups are part of the platform itself, and restoration is very easy, just a couple of clicks. You can even resize the database as you go through a restoration process, and that includes point-in-time recovery when binary logs are available. Performance is a topic that's often brought up, and one thing that I want to point out architecturally is that the CumuLogic software is not actually in the data path between the application and the database itself. Now that's a specific design choice that we've made with a keen eye to the idea that these databases, database systems that we're supporting, MySQL as well as Percona, have already been engineered to be the target for applications. And so what we really focus on is being a very good control plane. We take responsibility for that provisioning, monitoring telemetry, response to health issues, but get out of the way of the application users and the application owners in using that system directly. So apps don't have to be recoded. Now that has a performance implication. What that means is that truly the performance of the databases will be dictated by a combination of the infrastructure that you choose to offer the database service from, as well as the performance tuning capabilities and the selections of the end user. We do support the idea of scaling out as well as scaling up for databases, and different workloads actually would require different types of scale. In many cases, read-based operations tend to be the most frequent operation occurring against the database system, and so that's an example of where you can actually scale out very easily by adding additional read replicas to an environment. Sometimes, though, you need to be able to scale up, and that means resizing the instances that are running the databases themselves. That allows you to potentially just get more read-write throughput while also then scaling your read capabilities independently. We mentioned the parameter groups. We'll just talk about this very quickly again. This is an example set of MySQL configuration parameters that are included in the list of options that can be specified by either a system administrator, CumuLogic platform administrator, on behalf of the users as a set of best practices, or by the application owner itself that's requesting that database. And so you can see that it really does get down to very, very specific configuration values, everything from buffer pool sizes through max connections and cache sizes of various caches. Now let's talk about a couple of deployment scenarios that we support. Obviously, we do support single nodes. Those are great for dev and test. They make it easy for a developer to actually even have the development data be backed up. But much more interesting and more importantly are when you start to get to the point that you need to scale a little bit and to have production readiness for your system. So I've been talking about MySQL and the ability to have a single master read-write and then incrementally add additional read replicas. This is a very straightforward deployment model. There really is no system level limit, although there's some practical limits, but very little system level limit for how many read replicas you would add to that environment. You would funnel, the application would be built such that it would funnel write activity to the master, and it would typically balance the reads across each one of those read replicas. Different strategies for how your application can work that way. Now, when we start talking about clustering with Percona, as an example, in this case, we're doing something that's fairly similar, where you have a combination of both primary as well as secondary nodes in that cluster. Another interesting use case here is when you're configured across multiple zones to allow the read-write node to live in one data center or zone, and a read-only copy to be sitting in a secondary data center or secondary zone. Now, in this scenario, you actually might have additional read replicas on both sides. That's certainly possible, but let's focus on the failover scenario here. So in this case, the application's happily talking to the MySQL instance that's in region 1, zone 1. It's read-write. It's going fine. Then all of a sudden, something breaks. Well, the CumuLogic platform, based on DNS, will actually be able to support the automatic failover of that application's connectivity to the alternate zone. One thing we actually should have updated on this slide is that the alternate node, the replica, actually would be promoted to read-write in this condition, because it would then take over responsibility for that application. So that's an important attribute of many different database systems, and we really just make it a couple of clicks for an application owner to get that type of failover resilience. So with that, those are enough with the slides. Let me hand off to Sandeep Patney, and he's going to walk through the product itself with you.
Thank you, Chip. Hello, everyone. I'm Sandeep Patney, co-founder and VP of Systems at CumuLogic. In this part of the webinar, I will show you how easy it is to set up and manage MySQL database as a service with CumuLogic. So here we are on the dashboard screen. CumuLogic's MySQL database service provides users with fully managed MySQL and Percona XRDB database instances on any infrastructure. Users can launch dedicated database service, optimize it for their particular workload as needed. CumuLogic's unique SQL service allows you to manage SQL database from either CumuLogic dashboard, the user dashboard, or command line tools or RESTful APIs. CumuLogic database service is fully integrated with CumuLogic's platform, making it extremely simple for developers to deploy applications in any language, Java, PHP, Python, and so on, while making use of the database service in the back. So now let's go ahead and take a look how easy it is to provision a database service. So, so this is the CumuLogic dashboard. You see all the other service module services are available here. For the purpose of this webinar, we will focus on the MySQL database as a service. So here we see database service. Click on the details. Now from here, I have a pre-configured database bundle created. So these are something as an admin owner of the environment you can create for your users. I'm logged in as an end user, so I see some pre-configured configuration for a standalone database available with certain pre-defined configurations. So I'm going to click on that and say launch that service. So just give it a name. So I'm going to call it DemoDB3 and say launch, and that's it. So in few clicks, now you saw a database service called DemoDB3 is getting created. The action has started. Now under the hood, CumuLogic controller is communicating with the underlying IaaS infrastructure, creating that virtual machine, configuring this, creating the storage, configuring the required backup management software, all of that, installing MySQL. And once all of that, those steps are ready, the status will turn to green. As you can see here, this is in progress, and status will turn to green, and you would have the service accessible to you. So in the events tab is where you can monitor the progress of that service we just started. So you saw in few clicks, we are able to go from launching an instance, having it ready without having to worry about where it is installed, how it is configured, and so on. So that was just taking a predefined configuration. Now what if I wanted to do a custom configuration or a little more complex setup, such as creating a cluster or doing the multi-zone deployment like what Chip was just showing earlier. So from this screen, go here into launch instance. Now let's take a look how we can configure and customize these services further. So I'm going to give it a name again. So let's say I'm going to call it demo cluster. Give it a description. Here in the engine, now I can choose what I want. So whether I want to provision a MySQL or I want to provision a Percona XRDB instance. So I'm going to pick Percona here. We already provisioned MySQL. In the target cloud, I can choose where I want to deploy my workload to. So I have 3 targets defined. So I'm going to pick one of them here. So if I pick HP Cloud, for example, and then availability zone, I can pick which zone I want to deploy this into. So I keep that as zone 2. So depending on what configuration I want to deploy, so this by default is getting deployed as a cluster. So you can see there are 3 nodes selected here. I could increase the number of nodes by adding from here. The minimum requirement for a Percona cluster is 3 nodes. If I wanted to deploy a multi-zone deployment like we just saw, so here I will click on the multi-zone and enable that multi-zone support, and then choose. So primary zone I have already selected, so I can choose the secondary zone where I want to deploy the the service. Then I can choose instance type. So here I can choose what size of database instances I want to provision. So the available sizes here are I can pick from. So pick that. Give it a service tag. So let's say this service, whether I'm deploying this into my production deployment or development and so on. So I could go and deploy that, and then provide the basic information about what schema I want to create, what username, password I want to give, and so on. So I could give that, go on to the next screen. Here I can pick a parameter group. So this is the parameter group we just talked about here. So this is where you define your performance characteristics of your database. So if you don't have anything pre-created, you could just leave that blank. Default parameters would apply, and you could always come back and apply a performance parameters to your running database. So we are going to leave that and run with the default. Here I'm going to go and say storage size. So select what size of database you want to provision, and in the backup options you could provide your backup preferences, like the retention time. For example, instead of 1 day, I want to have a 5-day retention, and backup start time is given here. That's it. So once I have selected all of that, I go and click finish. So that will start creating Percona multi-zone deployment server. Now you would see that similarly this is in progress. The event will get updated here. So let's go ahead and quickly start provisioning a Percona cluster so we can come back and look at that. So let's call this cluster 1, choose that from Percona, and in this case let's put that onto a VM pool. I'm going to go provision that. So quickly we can see now that I have started provisioning a Percona cluster as well. So what we saw here is being able to provision in few clicks without having to worry about how the things are configured. The CumuLogic controller is taking care of the underlying configurations and provisioning those. Now the architecture you choose will impact on whether the performance or availability of the data and so on. So replicas, if you add replicas to your node, that will give you the additional read-only capacity, while the cluster gives you the high availability. And in the multi-AZ deployment, as you saw, that would be giving you protection from a zone failure. So it's giving you high availability across the zones and so on. So we have automated the provisioning, configuration, performance, optimization, backup, security, access control, and so on, eliminating the 75% of the administration task required to manage the database services. Now you can see here I have some databases pre-provisioned. So while these other databases we just started are getting provisioned, let's take a look at some of the management controls which are available for you. So here on the database, you would see in the bottom tab you can get the details. In the events tab is where you will see all the events related to that database instance. So for example, right from the provisioning, you can see here up to whenever there's a snapshot is getting created and so on, that would be displayed. Any errors happening during provisioning or after provisioning, those would be displayed here. So users would be able to capture that and useful for them to report any problems and so on. Monitoring tab is where you will get all the performance metrics. So like I mentioned, during the provisioning of the service instances, there's monitoring agents that gets configured, and they are collecting the monitoring metrics which are feeding into the controller. So you would see them from here. You could zoom into any of these parameters and look at the metrics graph. Access details is where you will get information about the database. Now how to access. So this is the access endpoint. You have the DNS endpoint here, public IP, private IP, and the private DNS name. So you could access the database with either way you choose to access. Here you have the port number, username, password. So now using this information, you can connect to this database as that master user and pretty much control that database, create schemas, upload data, or use that from your application and so on. In the usage metrics is where you see information about how much space is available, what schemas are in use, how much data is loaded, and so on. So if you're running out of space, you would know from here, you'd be able to take a look. So this is, like I said, this is getting a view into, there's no action available here. This is just giving you information about your running service. In the logs, where you can monitor your MySQL logs or your slow query log and general query log, you could see this. You can look at the logs here on screen, or you could download this log file for taking it outside for further analysis. Now let's see, CumuLogic also provides you the management action. So let's go back here and see what are the actions which are available. So you see that I have provisioned this as a standalone instance. I can click here. Now for actions, all the available actions would be available from this tab. You would see here now I have create read replica. So if I wanted to expand this database, I started with a standalone database instance. Now I wanted to add more replicas to it. So I could click on create replica. I could give it a name, and I could now deploy the replica either within the same zone where the primary instance is created, or I could pick another zone where I want to provision this replica. So I picked zone 3, for example, pick a size of the instance, and the storage. So minimum storage here is 20 gig because that's the primary instance provisioned with, but I could always provision this with a larger storage than the primary, and I could promote this replica later to use that as a standalone database. So here I would create on click on create. So that's start creating a replica node. Here we would see in the replica tab a replica node getting started. Now let's look at some of the other actions which are available, which are straightforward. You could restart the database, clone, or terminate the database. So terminate database will terminate that virtual machine, the storage, and return the resources back in the infrastructure. You can also so we saw while provisioning the database, we selected the backup retention time and backup start time. So we configured. So there is a default system backup that is running. You could always go back, and if you wanted to take an ad hoc backup on a database, you can always click on create snapshot, select the particular database you want to take a backup of, and give it a name and create. So that will take an ad hoc snapshot right at that point on the database. Now that snapshot, you could always restore from a snapshot. So you would see under the snapshots tab, you have all these snapshots which are available. You can pick one of them and restore it from that particular snapshot based on where, at what point you want to recover your database to, or you could delete the snapshot when you're done using that. Also, for restoring, we also provide you a point-in-time restore. So you could click on point-in-time restore here, choose which database you are trying to restore from, and you could either restore, as you can see here, restore it from the last backup, or you can also restore it to a selected time. So you could choose a date and time, and also choose a time at a 5-minute granular interval. So you can pretty much recover the database up to 5 minutes back in time from the current time. So CumuLogic keeps the binary logs for the database, and it can recover your database up to that specific time interval. So while this database, the replica is getting created and some of these databases are getting created, let's talk about the parameter groups. So we saw that we sorted these databases without any parameter group. Now under parameter groups, you could go and create the parameters, performance parameters for your database, and after you monitor your database for some time, you could always go back and would want to fine tune it, because we provision them with the default values. Creating a parameter group is simply just making a copy of the parameters which are exposed. So you could take one of the engines and make a copy of that parameter group. So I have made some here already. I can see a small DB, for example, and I will go and say click on view edit. So now I have all the parameters which are made available for this parameter group. So you could see key buffer size, query cache, and all of the MySQL parameters are available. So if I wanted to change any of these parameters, so let's say that I wanted to go and change, I would go and change, let's say, the max connections, which are 100 right now. I want to change it to 500. I will go and save that. So once I save this value, I can now go back and either when I'm provisioning a new database, I could choose this parameter group so that it gets provisioned with this value, or I could pick one of the databases and say modify that. Here I can change my backup preferences, or I can also apply, let's say I modified the small DB, so I want to apply that small DB. Now I have a choice. I can apply that parameters right now, so that if one of those parameters needs to restart database, it will get restarted right away. Or if it's a production database, you don't want to restart it during the middle of your production day, then you could save it and let it get applied during the next maintenance cycle. So let's say for purpose of this, I'm just going to go and click on apply it right now. So we would see now on the DemoDB4, and like I said, on the events tab is where you can follow the progress. So in the events tab, it will say now that updating the parameter group. So now it is going and modifying the MySQL configuration, changing the max connections, for example, we modified, and it will get updated on the database. So now let's see that I have, so one of the databases which we started provisioning earlier that got provisioned, and the status has turned green, so we can access that database. The access details are available here, and so on, the monitoring log, all of that information. So we talked about provisioning a multi-zone deployment where databases are, it can be automatically recovered. Now, for all of these instances which are getting created in the underlying IaaS infrastructure, there is the monitoring agents and the health agents. They are reporting the status, as you can see here. And if there was any problem like network connectivity issues or the instance going down or the whole zone going down, the status will be reported back in the controller, and controller would trigger a recovery mechanism. So it will, in the event of a multi-zone deployment, it will go and provision a new virtual machine, configure that back in the database, restore it back into that, and without users having to manually do any action, it would recover that database. Now let's take a look on the multi-AZ. I'm just going to demonstrate the recovery mechanism. So we see here the access details. We're going to identify what node it is. So this is Percona server -413. I'm going to go into my IaaS console here. So I have my instance list. I can see that Percona 413 is right here. So I have this ID. So I'm just going to go and abruptly terminate that instance right from the IaaS. So here I'm going to say Nova delete that instance. So this is running on OpenStack. So I can just terminate that from here. And now I can see this is getting deleted. We will just wait for it to see that it got deleted, and then we will go back to the console and see the failover getting in action. Just give it a minute. Okay, so that instance is gone from here. Now we will see that within a few seconds, the CumuLogic controller would recognize, it has recognized that it has turned to red, and we would see that the recovery mechanism for that instance will get kicked in. And in the events tab is where it will recognize So while that is happening, so I would also want to show you that how so all these actions, like I mentioned, you are able to do it from the database on the user dashboard. You can also perform all of these actions right from the command line APIs. So we would go here on, I open another shell, and I have my environment set up. So we have a command line utility called CLC that's available on our website for download. You could run command from here like database instance list. So the syntax is straightforward, as CLC is the command line tool, and now you have database instance list. This applies to all of our services. So you just go and say database instance list. It lists all the databases which are active right now. So you would see all the information about that those databases. If I wanted to go and say launch a new instance, I could go and give a command something like CLC database instance create, and then give all those parameters. So you saw on the screen, we selected all these values, give it a name, description, number of nodes, schema, and so on. I give all of that, and I would say go and create this. So it will return back and say, I can see here success is true, and we would see on the next screen here, I should probably see, yes, so DemoDB5 here, which I just started creating from the command line, that's getting created here. And the multi-AZ required the recovery we started earlier. Now we can see on the on this instance, we would see the progress. It has recognized that the instance has gone down, and now it is switching over because there was an active node available in the on the another zone. So it will switch the DNS, and the access details will remain the same. Application will reconnect automatically to that database. With this, I think we are almost out of time. So I'm going to thank you once again. I'm going to hand it back to Jack and Laura for opening on questions.
Thank you, Sandy.
Jack, back to you.
I appreciate the overview and the product demonstration. We have had some questions come in from our participants. And participants, I want to encourage you to continue to submit your questions, but we do have some that we will ask Chip and Sandeep. First is, what approach is CumuLogic taking to multi-tenancy in the platform?
That's a good question, Jack. I'm happy to take that one. So the way that the CumuLogic controller actually thinks about multi-tenancy is a couple of different things. So first, the controller itself is and its user interface are designed for a number of different end users. And each end user has its own account, and all of the resources that it provisions are specific to it. Now, the harder question then becomes, how is multi-tenancy achieved within the deployed systems? There's some database as a service platforms that choose to kind of be a single unified database platform, and they rely on some type of schema modeling inside of the database itself. But the way CumuLogic works is, since we actually use an underlying infrastructure as a service stack or a virtualization or virtualized environment, the virtual machine or the allocated system in the case of bare metal is actually the unit of isolation. And if we're working with something like OpenStack that Sandeep was demonstrating, each account within the CumuLogic controller is tied to an account within the underlying infrastructure as a service. So we get to take advantage of all of the inherent isolation techniques that are used down at that tier, both in terms of what's the network isolation model that's in place, relying on the hypervisor's capabilities to effectively isolate each one of the virtual machines from each other. But that also includes things like quotas for total amount of infrastructure that can be consumed by an end user of the CumuLogic controller via the constraints placed on that same user's account within the infrastructure.
Wonderful. Thank you, Chip. We have another question. What are the infrastructure requirements to make this solution work?
Sandeep, do you want to take that one?
Yeah. So from the infrastructure perspective, from the slides you saw, we support multiple IaaS infrastructures like CloudStack, OpenStack. We also connect to public clouds like Amazon, HP Cloud, Rackspace, and so on. Also on the private cloud side and on enterprises, vCloud, we support that as well. We also have mechanism for, like you saw in the demonstration. We also target the dedicated resource pool like VM pool here, so you could create those bunch of virtual machines and point that as a target for CumuLogic controller to be able to use as the resources. And as far as the CumuLogic controller itself is concerned, it can be as small as a single virtual machine deployed. It does not need a lot of firepower because, like CumuLogic controller is not in the actual data path of those services which it is provisioning. So it just needs to provision those services and manage them. So it can be a very small footprint on your data center.
Thank you so much, Sandeep. Participants, we want to encourage you to ask any questions you may have. Here's another one that just came in. Can you tell us what other database backend engines you support with your database as a service solutions?
Sure, I'll take that. So we've reviewed both MySQL as well as Percona within the relational database module of our platform. I will tell you that we have some additional engines coming in that particular module in our Q3 release. However, we also have our NoSQL as a service capabilities, which really is very similar to what we do with the relational databases. However, it's designed specifically to deal with some of the intricacies of the two engines we support, both MongoDB as well as Couchbase. So those are the additional engines that we see on the in terms of databases, both relational and NoSQL. But I will actually point out very quickly that those other modules that we have, load balancing, Elasticache, and queuing, have additional engines that we're supporting there as well. So for the load balancing service, today we deliver load balancing via Nginx. We'll be making a shift to HA proxy, and then we'll be enabling immediately support for Citrix NetScaler as well as F5 Big IP. For message queuing services, we support RabbitMQ by default, but if you as an enterprise preferred something like IBM WebSphere MQ, our current GA product supports that as well. And then on the cache service, that is in fact just an Memcached cluster, but a well-managed Memcached cluster.
Thank you, Chip. We have one more question. Here's a question that just came across as well. In the event of master failover, what happens to the read replicas?
Good question. So in the event when the master node is failed over, whether it is recovered into a new node or it is failed over to the hot standby, the replicas are automatically get reconfigured and pointing to the new master. So there's no replication loss as the master gets recovered at the same state where the earlier master left off, and the replicas get attached to the new master. So once the recovery is complete, all the replicas also pointing to the new one, and they start syncing from there.
Wonderful, wonderful. Thank you so much, Sandeep. Most appreciated. With that, that is all the questions that we've received, so we'll actually close. So we want to thank everyone for joining us today. We know that this was a big-time commitment. It's most appreciated. We also recognize that many of you are outside of the United States in different time zones. It may even be night for some of you, so we appreciate your commitment and your time. As a reminder, you will receive an email with the link of today's presentation within a 24-hour period. Also, we'd love to have you connect with us to keep the conversation going in any of these areas. Please feel free to reach out to us anytime via email. That email you can contact us at is info@CumuLogic.com. On behalf of our presenters and everyone here at CumuLogic, we hope you have a great day or evening, and thank you again so much for your time. Goodbye.
Thank you.